Hello and welcome to another episode of the CG Garage. This is episode number 408, featuring Culley and Richard Kidd over at Prototype. Culley is the CTO and Richard Kidd is the senior producer and digital human consultant. A fascinating startup company that's doing some very interesting work in the digital human realm. And they're looking at a lot of interesting things going on. Kristen, what did you think of it?
Oh, this was like a really interesting podcast. You're going to want to listen to it. At first, we get to hear a little deep dive of Culley and Richard on their backgrounds and how it led them to where they are now. And then we also get the inside scoop of Prototype and what they are doing with digital humans.
Yeah, really cool stuff there. Obviously, as you guys know, I have a fascination with digital humans, worked on the WikiHuman project myself, and I've done a bunch of other things in that area. So, finding out where that's evolving and seeing sort of what I would call, it seems to me that Prototype is working on some what we would call very, very, very high quality digital humans and leveraging a lot of machine learning on some extremely high quality data. So to me, it's really interesting to see where they're going. Culley and Richard are very knowledgeable in this area, and it was really interesting to see what's happening. Fascinated to know what's going on at Prototype, and definitely I'm going to be following them a great deal in the future. Okay, Kristen, we don't have any, since it's the beginning of the year, things are still in flux and happening. We don't have any new product announcements just yet, but we do have a couple of events going on the end of the month. So why don't you let people know about that?
All right, so you can find these out at chaos.com/events. The first one is going to be on January 23rd. It will be a free webinar, and it is real-time to photoreal with Inkscape and V-Ray for Revit. So that will be a fun one. And on January 25th, it will be another webinar. It's the tools and techniques to visualize an eco-friendly home. So you can learn how to render an animated virtual tour with Chaos Vantage and V-Ray 6 for SketchUp. So again, chaos.com/events to find out more.
Perfect. And that's on the January 23rd for the first one and January 25th for the second one. So make sure and follow us at chaos.com/events to find out more about those and how to register. And if you'd like to know anything about that. Great. And if people want to know more about the podcast, where can they go?
You can go to facebook.com/CG Garage Podcast or chaos.com/CG Garage. And if you'd like to watch us, go to youtube.com/Chaos Group TV.
Perfect. And if you have any ideas or questions or comments or suggestions for other podcasts, we'd love to hear from you. labs@chaos.com would be the best place to do that. I did mention it last time that I am doing a lot of research in terms of AI work, in terms of what we need to discuss on this podcast on AI work. There's a lot of ethical questions. There's a lot of technology questions. Tons of questions about AI stuff going on right now. And I really want to be able to address that and bring those to light. If you guys have any suggestions of those specific topics in terms of guests or what you'd like to hear, we would love to hear from you. Again, as Kristen mentioned earlier, it's labs@chaos.com is our email. Make sure and email us there. We would love some suggestions. I got a couple in the works that I'm working on right now, but any other suggestions would be super welcome. Especially what I'm mostly interested in, just so you know, sorry to drag this on, is different points of view. So if you have two different people with two different points of view about a certain subject, I would love to have both of them on and have a discussion between all of us and have more of a round table kind of idea. So please let us know. It'd be great to have that. All right. But for now, please enjoy episode number 408 with Culley and Richard Kidd from Prototype.
Welcome to another CG Garage, where the Chaos Group talks. You'll know it's over when the last bucket drops. We're gonna fire off rays in high dynamic range. We know that ambient occlusion is passé. Global illumination won't lead you astray. And while image-based lighting is really swell, you need to make sure everything has Fresnel.
As many of my listeners know, that I have actually had a big passion about digital humans for a long, long time. But actually, it hasn't been in in part of what I've been talking about for a while. I've been, wrapped up in things like NFTs and AI art for a while. So going back to digital humans is kind of like going back to your mother, kind of find, oh, I love digital humans, and sort of thinking about what they can do. But I actually, before we get started, let's get a little introduction to you guys, and then tell us a little bit about what Prototype is, and sort of get a little sense of where this conversation is going. So Culley, let's start with you. What's your background, and how did you end up where you are now?
Well, believe it or not, I've dealt with faces most of my career, so it's kind of a natural progression to the digital side of it. I've been doing beauty for about 22 years for pretty much any star you can think of. I've worked on them in the traditional sense, doing visual effects or beautifying them for their Hollywood look. For a very long time. So I started a long time ago at Rhythm and Hues, not doing beauty, but doing visual effects, and slowly got sucked into music videos of all things. And somebody once told me, if you learn how to do beauty, you always have a job. Which right now I don't know if that's going to happen because of where AI and digital humans are going. So they may have been wrong, but time always proves everyone wrong at one point or another.
Sure. Were you a flame artist over at Rhythm?
I was Chalice. I worked on Chalice. Yes.
Wow, I haven't heard that one in a while.
I was a flame artist, but I worked on Chalice there, and they had their own in-house thing called Icy, but I didn't get to work on Icy. I worked on Chalice. So. I'm the Grinch, actually.
On the Grinch. Okay. All right. That's a really cool show. Remember that one? DD worked on some other portions of Grinch as well. That was where I got some of my background. Okay, cool. Well, it's interesting. We'll talk about beauty work in a second. So that's your background in there. And what about you, Richard? What's your background?
Yeah. So my background is, I have a degree in computer engineering, specialized in computer simulation. Got in the business directly into visual effects. Worked at a small company, originally a small company called Vision Art Design and Animation in Santa Monica. And actually that is where I got my first start in digital humans. We were doing some TV shows for the UPN network, and I literally did digital doubles in 1994. Where, obviously it was at nighttime and it was a black suit and it was in the rain or it was really small, jumping from building to building. But that's, I started back then, and a year or so later I went to Digital Domain and did some of all the early R&D work for the digital humans that would be on the Titanic. Gotcha. So that just sort of started, and my whole career has not been exclusively digital humans, but just but I've always sort of had digital humans throughout that visual effects career. And then when I sort of retired of visual effects, I got into virtual reality, which then led me back into digital humans and needing photorealistic environments to sort of bring you into that virtual reality space. And so got deeper into got back into really digital humans, or got deep into it in the last 6 years. So so that's sort of my background and my sort of touch points with some of the touch points from the beginning to sort of more current digital humans.
Yeah, that's interesting. I mean, it's true. It was like people forget about some of those digi doubles were done for long time. So when people talk about digital humans, it's like, no, this goes beyond Benjamin Buttons, right? I was like, there was stuff that was being done, and in those days as well. And so you must have worked with Andy Jones and those guys over at DD.
Oh yeah, know Andy really well. He was, I think, he sat right next to each other.
It's funny you guys mentioned that.
So we worked real
I worked
closely
on a
together
talking dog show for Nickelodeon right about the same time as the Grinch. So it's full circle. Now we're doing talking humans. I don't.
Yeah, yeah, absolutely. Okay, so I noticed. I know. Obviously, I got in touch with you guys because I was chit chatting with a mutual friend, Eric Sanford, who also worked with at DD, and he's obviously told me, I was like, I'm working on this new company named Prototype, and we're doing some digital human stuff. So I am curious about sounds to me like you may not necessarily be able to tell us everything, but you definitely can give us some bird's eye perspective of what is prototype and what is it all about, and how are digital humans fitting into the environment that you guys are working on.
I can jump in there. I think,
Richard?
yeah. I mean, I think though the easy way to sort of look at it is that we are a digital human company first, right? There are companies that are visual effects companies that use digital humans or work with digital humans, but we're a digital human centric company. So we're about building and performing digital humans of the highest caliber and quality. So that is really what, there's people in it at different levels and trying to perform them at different levels and do little snippets here or snippets there. And I sort of described it to people as sort of, you think of a visual effects company, you might like build a digital human, but then you'll use it for 1 second here or 5 seconds here. You've got 30 shots in the movie or 100 shots in the movie. It really doesn't matter, but you're doing it specifically for these pieces, as opposed to building a digital human that then can be used in any number of ways. And obviously you customize it for different ways that you use it, but you're centered around the human as opposed to a project that might happen to use this and plenty of other things. So we're different from, say, a visual effects company that works in digital humans in that way, basically.
So would you call it a general purpose digital human?
I guess. I mean, it really is. It's really encompassing all the things that a digital human is, right? And sort of you're creating human beings that happen to be digital, and so you want all the talents and abilities, right, of that human, as opposed to a facade or a shell or, a visual representation. Yes, there are those parts, and depending on what you're using it for, you might only use those parts, but you also may get deeper into other ways. So, and when we're looking at the high end of the market, so it's really about, looking at the AI machine learned with the traditional CG approaches, and how do we use those different technologies to get what we need in any given scenario, and also not just in a given scenario, but for the best possible result, right? Like there's a lot in the space right now about how we use the different technologies to get the best looking stuff, whether it's neural rendering, machine learn and deep fake on top of CG or in place of, and you just get the best of all the different technologies, and how do you put those together to get the absolute best result.
What were you going to say, Culley?
And then, the purpose. What is it a existing person, a made up person? What's the project? It's just taking that digital human as an using them as an actor or a presence, and then moving that forward depending on what the project entails or what the people are in need of.
Right. So it's interesting. So let's say you have, I'm going to just say digital person A, right? Right. And so digital person A could arbitrarily be based on a real person or be based on a completely fictitious person, right? So like avatar helper person, right? That's another popular thing that is going on, right? So I want Alexa with a face or whatever I want to do, that person, you mentioned, Richard, several different techniques that are widely different in terms of a data set of what that person could be, right? You could either create massively detailed scans with pores and teeth and, all the fact shapes, or people are well beyond fact shapes at this point, but just all the different types of blends and motion capture technology and AI interpreted things, or you could go full deep fake technology to do all the way strange 2D morphing techniques that are done in deep fakes. So do you guys sort of encompass all of that inside of this human, and how do you capture that human?
I do believe it depends on the purpose, right?
Right.
We want to create our human to be able to be versatile. So depending on the task is where the technology will take it. So that's.
Yeah, I think wanted to add on to what Culley's saying is, like, I think We're developing technology. We're, using some existing technology and developing new technologies in all those different areas, right? So, and part of
Sure.
what we're seeing, and you can see in some of the research that's been done already, there are certain techniques that are completely independent, right? And then there are some where we start to overlay those two, right? Where you're doing, a CG, but you're adding neural network inferencing on top of the CG work that's being done. You can do it independent, but you can also sort of do that stuff together and get even better results. So there's a lot of research being done in all these different areas, and each one has their own, um, uh,
Pluses and
their own
minuses.
unique pluses. My exactly, like you've seen it, right? Deep fake. I mean, deep fake's been around for a while now. But
Hmm.
the question is, what can you do and what can't you do with those? And it's
Right.
just a straightforward deep fake. How do you get the advantages of that and not the disadvantages? And how do you weave those things together? And that's what's really important, right? About putting together a team that can think outside the box and also layer some of these technologies, right? So it's really about finding the best people, that can work together on these things. Because look, there's companies that exist already, the big guys, that do amazing CG work. And obviously they're looking into new things too, but they're focused on one thing and they do it really well, and they can just keep doing what they're doing exactly that way and make it just incrementally better and better and better. But there's whole new areas that open up when you can use some of these new technologies to get places faster, to extend things beyond, to extend methodology to be able to get characters built faster or do a specific thing. And so I think that's really what, sort of our advantage is being able to not have a legacy version, but build some of the state of the art and have really talented people from some of the best companies and some of the best projects on our roster, and continuing to build out, of course. But it's finding out how to work those things together.
Sure, 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 sure. Well, let's talk a little bit about legacy because I mean, I have a very interesting, point of view. I mean, I don't know if you guys remember, but I started something called the Wiki Human Project many years ago, and I was sort of fascinated by it. And the thing that frustrated me the most, and I think you guys will be sympathetic to this, is that so many people were trying to reinvent the wheel with digital humans, and everyone was trying to like start from scratch and didn't know, and they were like they got all this ingredients and they never knew how to put it together correctly. And they all kind of like took years independently of each other to do that. And I sort of got frustrated with that concept. And that's what I've sort of got together with Paul Debevic and sort of looked at what the data coming out of the light stage was. And sort of that to me at that time was like, this is the gold standard of data, right? If I'm going to look at the light stage, this is it. I've got very high quality geometry. I've got the best information in terms of color and in terms of specular and all of that. And if I technically put 2 plus 2 and get 4 out of the back end, I know I've got the right answer, right? And to me, that was sort of the problem, is that people were putting 2 and 4 together instead of 2 and 2 together and not realizing why it's not equals to 4, right? They was frustrated with this sort of idea. And I sort of always looked at it as like, listen, it's very simple. If you just scientifically put this all together, it's that. But things have changed since then. There's a lot more information you can do. You can infer so much more from less information that you used to. You don't need a 16K scan of a face to get all of the pore detail to get an accurate result. So what has changed? I mean, what do you get? What is your base level in CG? Do you still do scans of light stage scans and photogrammetry and things of that nature? Like, and what is like the good gold standard of data for people now?
Well, that's a really great question, and it's really deep. I mean, the funny thing was we were just talking to Paul about this the other day because we were just 2 days ago we were at ICT doing some scans. So
Right.
I mean, I still think that they're the gold standard in sort of the original texture data set and photogrammetry, just sort of getting this beautiful photometric, faces, textures, everything, all that high quality detail. Having said that, Epic is, through their group at Three Lateral and Cubic is, doing some amazing work, obviously with everything that they did with MetaHuman. Now that's for, squished down to the real time world. but the data sets that they're sort of putting together and what they're sort of developing out to do, the next generation of this, right? And that's one of the things that we're sort of looking at as well, which is what is that data set that you need to feed to be able to create these things without perfectly scanning, because if you're not perfectly scanning one person and recreating that exact person and you're creating something new, where do you get the variety and the detail and the texture and the stuff from? Well, traditional ways, you go and you scan somebody that's close and then you make your changes and you do some stuff. So I think that, but what's the future of that? Where does ML fit into that space, right? If you're going to machine learn that and sort of create variation, create differences, create something very quickly without having to go back and get all that and rebuild everything, that's really interesting territory. But it takes a really massive data set too, right?
Right.
Right. What is that data set? I mean, you guys have a data set that's that big that can learn from all that stuff? Are you guys deriving that? Is that part of what you guys are building?
I don't know that we can talk to the details of what we're building per se, but I would just say, like, in generalities, is that data set is massive. So I think it's safe to say no one has that data set yet.
Right.
I mean, I don't know what Apple or Google or Microsoft might have been scanning for the last couple of years, but it's from what most is out there. I don't think there's too many people that have that data set to be able to generate that stuff. So it is still sort of build it as you go. We are looking at building that data set as far as what we need to develop our technologies and go forward. So whether that's 100 humans, is it 1,000 humans, is it, what is that, and what are the variations that you need in textural detail and physical shape in order to sort of build that to sort of create, I won't say not that we're doing this, but I think that it depends on what you're doing. Like, are you trying, MetaHuman is sort of building this giant, great, generic, build any human kind of system. And it's amazing what they've done. That's a little different.
There are some constraints to it, though. Like, you can't really push it that far. It's like this much.
And that's what I was saying. Is like I think even they don't have that data set yet. Right?
Sure.
Like they and I think it's it's that it is constrained. But I think you can see that probably growing significantly.
You definitely see it coming.
Yeah.
You definitely see it coming, especially with the stuff that NVIDIA is getting into with nerfs and inference from the nerfs, taking just a few photos of somebody's face and being able to extrapolate it using nerfs. That is where I see, a very fast prototyping, pun intended, of facial creation coming for the masses. Now, whether we want to do that or not for the masses is the question. I think want to specialize a little more into the film quality, actor, singer, Hollywood area than just a generic face, depending on what the project is. I mean, if we get called to create a bunch of, generic characters for crowd duplication, maybe that's what we pump out real quick using some kind of quick algorithm to put out a generic human. But the NVIDIA stuff is just insane. What they're coming up with. Did you see the newest one was with 3D text to 3D object?
Yes.
The newest paper. That looks really cool.
I mean, it's to me the one of the things, like you mentioned nerf stuff. I was fascinated by it because the thing that I find fascinating is, like, obviously, this is before a lot of the ML stuff was going on, going back like 8-10 years ago at ICT. They had a ton of lights and they had a ton of cameras, right? And not a ton, but they did a lot of data based on those lights and cameras that they could get. What Nerf does is says you can only need 10% of that and we'll figure out the rest in between, right? Exactly. It's like the best in-betweeners out there is that the AI stuff is doing, is that it's right. And it's figuring out all the steps in between so you can do much more with much less. Which I find really fascinating. But I do want to. Sorry, I'm jumping all over the place because, like I said, I'm going back to my love of digital humans. When you're capturing all this stuff, and you mentioned you're wanting to capture a ton of different types of data. Obviously, I can imagine a ton of different humans That makes total sense. But within each human, like when I would scan a human, we basically had like our normal set where we have a facial expression and then we try to do all the fact shapes, right? Like that was the basic way of doing things. Is that still a case? Is there a new type of data set that you want to capture a person that is better than fact shapes, or that, because ML, like fact shapes don't really make as much sense as they used to, right? People still use them, I guess, but it's not really.
It depends on your background system and your rigging team. There's many different ways to go. A fact system is still great reference. 4D capture is the new gold standard in this area. So you can get the in-betweens of the in-between, right?
Okay.
So you can get all the facial
Explain a 4D
expressions.
capture system for our listeners here.
4D capture is when you have multiple cameras running at 60 to 120 frames a second to capture the fact shapes or performances, full-on performances of a whole song or performance of what you need, or just capturing the fact shapes. The fact shapes doing your usual, the standard shape to capture a face so it can express emotion and words is the fact system. And doing those positions and then moving in between, it gets all of that. Instead of taking one image for one fax, another image for another fax, it gets the in-between micro expressions of the skin and the blood all compressing and decompressing and deforming. So you get that person's essence. So the 4D capture captures not just a moment in time, but all
the moments
time
between those times,
yes.
Right? And that was always the problem I always had is when you looked at facial expressions, this is all a traditional thing, is like you can tell when they hit the expressions, but it's in between, it looks CG.
The in-betweens are always the problem. So this is number one, the solve is a 4D capture. Number two is machine learning for rigging and facial expressions.
Yeah, I think and that's the interesting thing is that, right, it's sort of like, the easy way to think about it is just, right, 3D capture, right, you're getting 3D from that still image, right, because it's lots of images, right, and you're reconstructing in 3D. The 4D is, right, just adding time. So you basically getting to see that through time and seeing all those details. And the next layer, as Culley was mentioning, is like, then you got the machine learn part. Well, the machine learn part it's an interesting because it's like it's not like one thing, right? Machine learning is a technology that can be used at any layer or any part of that process, right? And so you're sort of learning from the data to be able to recreate things with a whole lot less overhead, right? You're not calculating everything. So you could find ways to simulate. And that's what we've always done, right? We simulate things in CG and we try to come up with hacks to do it so it doesn't take up too much CPU or GPU. But now it's sort of like, no, I'm going to build a machine learned model. Now you got to give it a lot of data so it can build this model. But once it does that, it can, essentially render or create whatever you want it to create very quickly and with very low overhead. And so that's
where does that data come from, though? A 4D scan.
A 40, right. Okay, so a lot of 40 scans.
A lot of 40 scans, yes.
Oof, that's a lot of frames.
Okay, so now you're getting into a whole nother, right? So now huge data
talking
set, right?
hundreds of terabytes for one character.
Petabytes per character, yeah. Okay.
Yeah. So
I see where you're going.
Yeah, and so what you're really looking at, so when you say fact shapes, right, it's still this, you're still getting fact shapes, right, when, and with 40, you're getting more than that in the in-betweens, but it's still about getting those shapes. It's now just about, because you can get those shapes and you got those extremes, and then you get the in-betweens. With the 40, you might be doing, have them do a performance and say, the quick brown fox, jumps over the fence or whatever, your visemes or your phrases to get them to move into all their positions. But it's about sort of really developing out like all the opportunity, all the ways that you can do it. And then by creating all that data and the video from that data, you can then, learn, the model can now learn, and now you're not having to recreate that hard coded essentially, and you have a more dynamic approach to being able to do things. I mean, we've seen that, right, like Ziva, I think recently was showing off some of their technology with their machine learned rigging, right? So that's what I was saying, you can put in step of the process where you feed it a lot of data and then it rigs it based on, the data that you've sent it. It's like, oh, okay, we can auto rig something to be able to do all the stuff that you want it to do based on the data you gave it, told us what you wanted it to do.
Interesting.
And then once it does that, you can then do things like, again, feed data to things to analyze it, to kick you back out in animation, right on there. So again, that just gets to sort of like retargeting and animation stuff, and you're feeding something video and now getting it to automatically, spit you out an animation onto that rigged, object that you've already created now with this data set. So all kinds of like automating these processes that used to be traditionally very intensive, like work for the artist to do. You got an animation department, you got your rigging department, modeling department, your rigging department, your animation department, and everybody's doing this by hand, and you're tweaking little cheeks and little snarls and flares and like I said, blood flow, and like you're sort of like, okay, how do we get this to go here? As opposed to doing all that hand massaged hand work, you're creating a model so that you can generate. It's not the end all be all. I mean, maybe it will be eventually when we have these massive data sets, but it's the difference is sort of creating something very specific to do exactly what you want in that moment. So sort of back to that sort of visual effects example, like, okay, I've got 5 seconds and I just need it to do this for this, all these things I need to hit and do in this 5 seconds, versus creating something that you want to fit and be able to sort of do everything. And the difference is you can do a lot of work to get one specific thing, or you can do tons more work, building the model, the data set, whatever that thing is, to sort of to get everything and build something that now when you go to use it can just do what it needs to do, and you can do it a whole lot faster and a whole lot quicker. So it's like building a much bigger, wider, deeper base foundation. And then from that, you can move a lot faster than traditional methodologies.
Okay. Do you guys remember Mark Sager and Baby X?
Yeah.
So that was a fascinating project, and obviously Mark was trying to create a complete CG human with Baby X and neural networks of their brain and everything else. But Mark also did something a little bit different about the way the faces were moving, is he put a muscle system into the face as opposed to doing a fact shape system. Is that still something that, you mentioned simulation before, is muscle system something that is still something to consider in terms of facial animation, or people still relying mostly on blend shapes at this point?
I do believe it's still a combination depending on the end result needed, and what the artists sometimes are comfortable with, right? As we just talked about earlier, Ziva has a muscle system that is trained by 4D facts, by 4D data in machine learning, and
it derives the rig based on that, right? Yeah,
based on the muscle system, and it can do it for not just faces; it does it for bodies and hands and fingers and characters. I think in the grand scheme, a muscle system is still probably superior, but depending on the job. Like if it's just a face, I feel eventually it'll have enough training. It probably doesn't need the muscle system underneath. Right. But if you're doing a character that has never been done before, a muscle system would get that to the next, it would infer the right stretching and pulling and popping to the right places. So it all, as usual, depends on the project or the end result.
But I think that's really right. That goes to the base of like what you're trying to achieve and where things are going, right? When you look at what we're doing now, or what has been done, what's being done now, and then where things are going, which is, traditionally we're always like, hey, we need to make it more real, more real, more real. How do we make it more real, but making it more like reality? We just had the flesh on the skin originally, right? That's all we could sort of go. And then somebody finally went like, well, wait a minute, if I actually put a muscle in there and get that, enveloping and that to sort of push out the skin. Even in Jurassic Park, right? They were doing that. Right. So create that muscle system, sort of push things and sort of get it to be more realistic. But you got to simulate all that stuff. And of course, we were hacking it because you could only do so much, right? With the computers that we had at the time. But it's like you're hacking that system to sort of simulate a version low weight version of a muscle system to sort of create that skin bending and shaping on that stuff. Well, what we're going with, as we move forward, right, is you're getting more and more of that. Where can we bring in the machine learning? Where can we bring in the AI that doesn't require us to simulate it, or we're simulating essentially in a different way, right? We're getting tons and tons and tons of data that we feed in, and then we get out good looking stuff because we've given it so much that we can do. And obviously there's algorithms and a lot of work that goes into that, but it's once you've built that, right, you then just sort of keep tweaking and tweaking, but you can just spit the stuff out. I tell people it's sort of like the difference between, if you're doing like a real-time human, like if you're doing a real-time human, you're going to have to put a lot of workload in, right, to get it to be really good. But then once you're done with it, and at whatever level you think is good enough for you, once you start using that, right, you can do 20 minutes of content in 20 minutes. You're just performing that character in real time, as opposed to, the traditional sort of CG approach of like, we're doing this for a movie and it's got to look perfect. And you're like you can do a 10-minute segment in a movie, right? And it takes you thousands of artists, years. Yeah. And you get that 10-minute segment. Well, now you got to do another 10-minute segment. You're basically starting over from scratch, right? Sure, you're carrying a little bit, but you're not carrying a lot of that. You're starting over, as opposed to the, creating the foundation that you then get real-time content, like that. And it's sort of this similar kind of idea of like, hey, you can simulate everything, but that's going to, and theoretically that's, the way to go if we could just get it all to work. But the amount of compute intensive that it takes for that, if we can now use maybe some of that simulation to feed the model to be able to kick us back out. Yeah.
So it's interesting. Sorry, go ahead. Finish up.
No, I was just to say exactly that. You use that to feed the model, but that takes a lot of data. And then you just go, okay, well, where else can we feed? Where can we cut some corners so that we don't have to create this massive data set? I mean, it's sort of like looking at the whole, autonomous vehicles, right? When you look at that kind of thing, and the whole thing of like, how many billions of miles driven do you need to be able to feed the model to teach the cars how to drive?
Right.
It's a similar kind of process.
Yeah, for sure. Now there's different ways. Obviously, I've been looking at digital humans for a long time. I started to get interested in, obviously, when I saw what is possible with Benjamin Buttons. But then, it became a very big deal, as you guys, I'm sure, are all very aware of this. When they made Digital Tupac, it was like, hold on a second, right? And then there was this big like ethics question that was happening. And then obviously, as you know, with deep fakes, it was like, oh no, it's going to completely change. I actually hosted several panels before the election where it was like, the election's going to be completely changed by deep fakes. It turns out, you know what? You don't actually need deep fakes to change an election. You just need to tweets. Just a few tweets and straight up lying works just fine. So, so the digital humans had nothing to do with that. But what is interesting to me is like, okay, obviously, like you look at Digital Tupac, which is the entertainment side of thing, where people are like, oh yeah, I want to see my dead celebrities or those types of things, right? And then you also look at like Baby X, where like, I'm just going to completely recreate a human inside of the computer and try to make that happen, right? And then you look at these in between parts, where it's like, I want an avatar, I want something for my virtual reality space, for my game, or some kind of interactive human of some kind. Where are you guys in the middle of this mesh of stuff? Because you've mentioned a lot of R&D going into feeding a data set to make the digital human faster and easier and more real time. But where are you guys in between that? Are you guys creating that so that the entertainment side becomes easier? Or are you creating that so that you can create an autonomous avatar of some kind? Or are you everywhere in between of that?
I think that we can say that like there's obviously at this point we're focusing on that sort of very high end entertainment version of the photorealistic, huge digital human. So
okay,
where does that go from here? I think we have a lot of avenues that we're looking at, but day one, are we building the fully autonomous AI brained, digital human? Like I think it's safe to say, after all the, a decade of Apple and, Amazon trying to create Siri and Alexa, that we know that the fully autonomous AI brained, just digital helper doesn't exist, right? So the idea that we're going to create that also with the visual representation, I think
Andor
we're not.
doesn't even seem to be profitable for Amazon. They're
I
just
was
come out
just
with
going to
that.
bring that up, Culley.
So,
They're actually they're going to cut the funds on Alexa because she's not making enough money for them.
it's a loss leader. It's not really anything that seemed to turn out well for them.
Apparently, Amazon doesn't make money when people ask it what the weather is.
Yeah.
I mean, we're looking at the entertainment side at
Okay.
many different angles and strategic alliances with different people or entities to bring these to different areas, right? And,
Okay.
and we can't elaborate too much, but we can't. We're a very small startup, so I think we're about bringing a lot of different things together and not necessarily reinventing the wheel, but trying to find the little pieces where we do glue them together, right?
Right.
Because we can't be ILM and we can't be Epic, but where's the pieces in between we can fit, and hopefully
Right.
we can find those wedge areas and make some amazing things.
Yeah. I mean, I'm sure there's sort of a something. Was that yours, Bell, or my bell? No, it wasn't mine.
Sorry, no,
I think he dinged in for the answer.
Yeah, exactly.
What is digital human?
Yeah, that was pretty good. What was so I'm sure there's also thinking about just scanning people, right? The idea of creating digital archives of people at a certain point in time is also something that I find is very interesting as well. Some people, obviously you guys work on high end and you're looking at a lot of stuff in Hollywood. I'm sure you have connections. You guys are based in LA. I think you're based in LA. Is that correct? You are based in LA.
Yes.
So I'm assuming that you guys have mixed reactions from the Hollywood base about digital humans. There are certain people that are like absolutely no, like they put it in their contract of no digital humans or whatever, like trying to protect their identity or their things. And then I'm sure there's other people like, you know what? I kind of want an archive of this.
I'll tell you what, when they start looking at the money, those contracts, they look thinner and thinner.
Right.
It's a whole new realm. I think it's becoming thinner and thinner, the pushback, because people are starting to get used to the idea. I think there's a lot of people that were always saying no, that see the potential and the interest in something that has never been done before. I mean, it's not just a realistic digital human. You could do that, but where do you take it? You could take it to places we don't even know right now. So I think that people are starting to think about that and want to explore those areas, and the archival process or the extrapolation. Like, where can we take this? It could be me, but better or bigger, stronger, different looking. The creativity here is where we want to strive, and we want to look at and take that to a different level.
Yeah, I think it's really important to just really step back and look at the macro, right? I mean, this is sort of like the idea of like, from radio to television and people going like, yeah, this thing is a gimmick. Like, what's going to do? Or, I got one channel or two, this is, I mean, it's the future and people will all accept it. It just takes it takes a lot of people a lot longer than some of us. So, I mean, the thing is that you look at it, no one has a problem watching Minority Report, right? And seeing Tom Cruise run into a mall and a billboard start talking to him and selling him a shirt, right? They love it, right? This is like a future.
Worked on that.
Yeah. They're like, this is amazing, right? But then when you start, you're actually implementing these things and you're going like, well, how does that work? I mean, I think just even a couple of years ago, there's digital idols in China, right, that sell out concerts, right? And those aren't even photorealistic. We're talking about, anime style characters. You look at Hatsune Miku out of Japan. these are very successful things. You come over the West and people are like, yeah, but are Westerners going to be into that? And you're like, well, first of all, Westerners are, only a small part of the globe, but you start to see it. I mean, look at ABBA Voyage, right? ABBA Voyage in London, is, I think it's 6 shows a week, or 6 days, 2 shows a day or something like that. I mean, they're selling out. I mean, it's, for those people who aren't familiar with it, I mean, they recreated the Swedish, pop band ABBA from the 1970s, and they're doing a stage show with, digital recreations, and it's amazing, and people accept it, and some people think it's real, and I think that it just takes time for the general public, but the reality is it's a no-brainer. I mean, if you had an Alexa next to your bed that had a visual representation, and you could talk to her, and and you would buy more stuff, right? It would be worth something. I mean, we already know, like, there's been multiple studies done over the last 6 years, especially in relates to the VR space and AR space, which is, if you have an emotional connection with a brand, you're much more likely to buy. You're also more likely, you're likely to buy, I think, twice as much stuff if you have this emotional connection. So a physical representation or a virtual, representation of, visually that you can see, and not just talk to Alexa, right? One of the biggest problems with, these assistants is you never know when they're listening, right? And people don't like that. Well, if I have a visual representation and I know when she's listening and not, I'm going to feel a lot more comfortable having her in my space. I'm also going to be comfortable saying more things to her when I can see her like a real human being. I mean, I think it's pretty safe to say that most of the large internet companies are working on some visual representation, sort of the next level of the internet. I mean, if you think of chatbot, and every website you go to, there's a chatbot.
AI customer service.
Yeah.
Hi, I'll be your customer service agent today.
Right.
Well, and even from a luxury brand standpoint, right? I mean, you go to a website and every single one has a little chatbot trying to help you out, right? But if actually a face popped up of someone that was attractive to you, that fits your mold, and says, hey, welcome to the Gap, or whatever it is, how can I help you find something? What are you looking for? And you're like, well, I'm looking for some tops for a male, or I'm looking for tops for a wife, or,
Right.
or
And then it pops up and it's got the shirt on. Well, how about this? You could have a virtual shopper right on your screen. You never know where it could go.
Right. Yeah.
But I think that is something that, to understand, is that a visual representation of what we're interacting with is so much more engaging, right? And it's so, and it's faster and it's easier, right? So I think we can look at it in those consumer models, to sort of understand that this is just the future. It's not a question of like, how weird is this? How strange is it? Do I want my representation? Of course, you're going to want your actor representation to live beyond you, because your estate's going to be making money, as they continue to put you in movie after movie, even after you're long gone. And that sounds a little weird now to us because it's never been possible. But when you think of the possibilities and you can extend yourself, it's only natural when you look at the extension that's happening right now in this space. If you're a pop star.
Well, look what Bruce Willis is doing.
Yeah.
That was a rumor, wasn't it?
No,
the Russian company that bought his likeness.
Was it a rumor or was it a reality?
I think it was a rumor. It was fake news, actually.
Really?
It was. Well, I'm confirming with a fact checker, but I remember saying that it was fake news. I don't want to say it if it was false, but I do remember. I was like, oh, that's really interesting. Yeah. He denies selling his deepfake rights to anyone. So it was a fake news article, but it's totally believable. It's going to happen.
Yeah, exactly. I was going to get it. So the other people I was talking to was the Corridor Crew guys, right? And they used a bunch of deep fakes. They put Keanu Reeves into their short, right? And I'm like, oh, okay. And it's like, well, I can't afford the real Keanu Reeves, so I'll just use a deep fake version of him, right? And it's like, well, duh. Right?
And then you get into all these rights and copyrights, and there's so many legal questions going forward from here.
Right.
What if Keanu Reeves is doing a commercial in Russia? What recourse does he have? Probably none. So it's
right.
a weird. It's also a very weird time to live. Like
It
your
is
likeness
interesting.
can be used against your will. So
Yeah. I was
it's an
actually
interesting place.
I was on a panel with the SAG-AFTRA team that were all concerned about this whole thing as well. And was like, and that was sort of the same discussion that we were having. It's like, well, part of you is going to want to have an archive of yourself because of exactly what Richard was saying. And then part of you is going to go like, but wait a minute, what if someone got that data and they could start taking, using it
Well,
without me knowing about it?
maybe like music, they have those restrictions when it senses the wrong music. We need to come up with a visual system that matches. Oh
Right.
crap! There's
Yeah.
an idea.
Yeah.
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 That's
There is
all
actually,
right.
there are people,
New
there are,
business plan.
there are definitely deep fake detectors that are out there. There was another guy who I spoke to who's been developing some of that technology as well, specifically to fight fake news and things of that nature. But
Yeah.
it doesn't
I
always
mean, I
work,
think,
you know?
yeah, and I think, but I think what you have to look at, right, is that these are the kinds of things that these problems are going to arise, right, and then they'll create new problems with and new solutions, and more people. Somebody can develop that software, like you're saying, a deepfake detector, and now he's making money off of that. I mean, I think the reality is like, look, we don't stop making movies because they get pirated in
Even
other countries, right? I
even if
mean,
it's
Right.
a
and those
deep,
get
even
taken
if
without they get taken without the desire and of the companies that own those rights. And
but
we
then
work within our governments to be able to sort of
right,
minimize these kinds of things. And I
like
think it's going to be the same thing.
right, exactly. It'll just be, deepfake detector is one thing, but then if it's detected on YouTube, then they monetize their image. Like, oh, you use my image, well, I get that advertising now, just like the songs may. Or it gets
Right.
blocked completely if it's on a legitimate site that is detecting those things. You either monetize it or it gets blocked. And the other
Yeah.
part is, back into parody, or there's a lot of different directions this could go. So I'm sure that Congress is going to be making all sorts of new laws, and ASCAP and
Well,
everybody, or not.
yeah. I mean, this has come up a few times. We're talking about what governments are going to take over, but unfortunately, when, as you guys know, when this type of technology, especially any kind of ML or AI technology, starts to get developed, it's so hard to try to control that. I always liken it to saying it's like trying to take pee out of a pool. Like, you're just it's just there. You're not going to deal with it. Like, you just it's just there. But I'm
Well,
trying
there's
to, go ahead, Cully.
well, yeah, you're not wrong. It's always going to be the fringe or whatever, but you could lock it down with blockchain, but there's always ways to get around anything. It's just a
Sure.
matter of how, the cat's going to be out of the bag no matter what. But there will be ways that you can lock something down and monetize it,
Right.
and actually get the value of the creative, and hopefully make some money from that creative, as every artist wants to.
Sure. Well, and then sounds like you guys are going to be able to help them out either way.
Hopefully.
But okay, I want to go back to an old school topic in digital humans and sort of see how far we've gotten. Let's talk about the uncanny valley. Obviously, this was the thing that people were talking about for so long, and there was a lot of things that were being done to sort of fight the uncanny valley and figure it out. Well, there were several things that I was thinking about. People were thinking about the in-between shapes. We mentioned those earlier, it's like the points between the fact shapes and how that could help take the sting out of that effect of the uncanny valley. But I was also thinking about, what is machine learning doing to be able to make those difficult uncanny valley moments happen? Because honestly speaking, between you and I, when I look at a metahuman is very deeply in the valley still. I mean, it is very,
Oh yeah.
very good. And that's part of the problem, is that it is a very, very good real-time human, but it is so good that it's falling hard into the valley, and it's going to be, sorry, it's going to be a big effort to get out of there. So, what are your thoughts on the uncanny valley and where machine learning is going to be able to help that process?
Well, I think it's I think when you talk about the metahuman stuff, I think the reality is their focus is purely on real time, right?
Yep.
And so at least right now, and obviously as GPUs get faster and faster and CPUs get faster and faster, they just sort of win and they don't have to do anything additional for that. So they're sort of building that foundation for the future. But yes, trying to squish it all down in there. I think like we're looking at like, if you look at just like blend shapes for the face and facial performance, because that's really what, metahumans are really about the face at this point. If you're looking at a film visual effects facial rig, you're probably looking at, upwards of 750 blend shapes. Now you might do it with less, but it could be as high as that. If you're looking at, something, game or real time related, first of all, you don't really want to use blend shapes. You're probably using, bones, joints. But it'd be vastly, if you use blend shapes or something like that, you'd vastly less, probably 150, I'm guessing.
Well, that people just use the apple shapes now.
Yeah, sure. But I think that as far as like where does the machine learning go for it, like machine learning is really about taking massive amounts of data and applying it in ways that would take you way too long to do. So it's really just sort of like the simulation that we're talking about. Like, so I think one thing that we didn't touch on before is like machine learning and sort of where does it go in that process. We were sort of talking about a little bit, but like the idea of like machine learning or machine learned models or for cloth and hair, right? Where you're like, the idea of simulating the cloth is incredibly heavy and time consuming. And if you can apply machine learning to that to get significantly better stuff way faster. And I think the same thing when you're talking about uncanny valley, right? You're talking about like the tiny little wrinkles in the face and stuff like that and how they go together. Well, we're talking about the 4D capture. It's all those like tiny little details that your brain registers, but your eyes don't necessarily, right? Like your eyes see it and the brain's registering it, but you're not visually going, oh, well, this is what's missing, or this fine detail, or this crease, or this wrinkle, or the way that it moves. And that's what you're going to get from the machine learning, right? You're going to get this massive amount of data that you can put back onto that thing without going like, oh, now I got to carve this extra little crease, or first figure out that problem. You don't even need to figure it out. You're just feeding it lots of real data, and it's essentially processing that for you and figuring it out, if you will. And applying that to the new thing. And I think that's the same thing, like mentioning like hair and cloth, like instead of trying to realistically simulate that or get, just tons and tons of pixel detail there, right? But actually getting that over time and the movement of all that kind of stuff and applying that. And I think that's what really solves the uncanny valley. And I think that's how you get there. So it's not like, it's sort of it's the hop, sip, and the jump over, right? Like you could keep incrementing the CG side of it, the traditional approach of getting it to work, and you could maybe eventually get there. But it's the massive amounts of data that we can't do, and why we try to short circuit that.
You could think of this. You could think of the machine learning as kind of a compression, right? It's virtual human compression. You're taking all this data, whether it's animation, look, lighting, skin, texture, and you're compressing it down into a thing that can be put out in a high quality way without having to have all that data behind it. It's compressed and you get that image out of it. And that's the way I think that it's going to happen. And I think it's a good explanation of what it really ends up as.
That totally makes sense. I want to touch on one more thing because I think this is something else that let me know if I'm right or wrong on this. But one of the other issues I always had especially when I saw people back before the machine learning, a couple decades ago or a decade ago, wherever, trying to figure this out, the problem they had where they would always fall into an uncanny valley is that they created a negative emotional response, right? And so they would overcompensate to get rid of that, and they could never fall into where they needed to be in terms of, like, I'm just talking about just pure animation, for example, if they're doing a facial animation, is that like, oh, because they would have this very subjective view of what they were looking at, why they knew it was wrong, but they didn't know why it was wrong. And they would overreact, and they couldn't get the fine details, and they couldn't get a purely objective view of the digital human they were looking at. And it sounds to me like the machine learning can remove that emotional response to that thing and just purely focus on, it just needs like that 3%, and then you're done. You don't have to do 35% of or whatever it is. Does that be true? Would you guys feel that's true in some ways?
I do believe
Yeah,
that. I
absolutely.
have a.
Go
Go
ahead,
ahead.
Culley.
Go ahead.
No, sorry. I have an example. If we can share a screen of a little thing that we did that can see a
There is
little bit
actually
of
a share screen, and so unfortunately, people who are listening to audio we're going to have to describe it to them. But there is a share screen, and there is a video version of this, and I'm willing to put it up. So if you go to the bottom, you'll see something called share there. Yeah, there you go. Right. Okay. So I'm looking at an eye right now, and I'm looking at eye movement. Right. Very close up.
So as you can see, the fidelity and the reflection and the subsurface scattering, and we're changing the makeup on the fly right
right.
now. And then you can see the wireframe and
Right.
a little the overlay of the wireframe here. So
Sure.
I just wanted to show you that real quick. It's just a little tidbit of what we're doing.
Yeah. That's very cool. Eyes are obviously very, very important. There was a video I remember watching years ago. It was actually a research out of MIT, and what was interesting is they would take videos of people, and people just standing still, not even moving or anything, just straight video of them holding still. And what they would do is then they would take sections of the face, and they would look at that face, let's say on the cheek right here, and over frame to frame, they would look at differences in color between frame to frame, what it would be. And they would take that difference and multiply it by 100, right? And then suddenly what they're doing is you saw the blood flowing through the face, just the pulse, right?
The pulse.
And so what this sort of reminded me of was a thought that I had a conversation with a friend of mine who worked, who was in the Iraq War, right? And he had said at that point, he says, and he worked in visual effects as well. And he said, I remember seeing a dead person for the first time. And it's a little morbid, I'm sorry, but he said he saw a dead person for the first time, and there was nothing about the face or anything that would imply that there was no facial problem, and it wasn't shot in the face. Let's just put it that way. But he says immediately when he saw it, he was like, that person's not just lying there, that person's dead. You could tell, right? Like there's an emotional response that happened. And as we were looking at that video, he was like, I think we see the pulse. We just don't realize we see it.
That's funny. That's funny you bring that up, because I was literally having this discussion with somebody the other day. And that was the idea. It was like, you know what, if that's the difference, like, if you have someone lay there on the ground, right, there's also, even if you sort of like feel like there's less, color in their face, or you've made them up for a movie,
Right.
you still sort of see that, even though you don't know it, versus the idea of like completely, once you've stopped that blood flow completely, you don't lose the color, but you lose the dynamicness of it, which we would never register seeing that. Exactly what you're saying.
There's nothing you can actually point to. It's like, I see the colors, but the point is that you would see it. And what's very interesting about this video, by the way, is that they could do it on nearly anything. They did it. They took film from Batman, highly compressed, crappy YouTube video from Batman of Christian's, what's the name? Bale sleeping in the darkness, and they still were able to get that blood flow to go through that. So we see it in almost everything. And it was a fascinating sort of thing to see. Like, I was just thinking about that. It's like, that's the thing that's makes us feel live or dead, right?
You've made me think about a new way to, do dead people in visual effects. Just take a still and track it over their face, so there's no actual blood movement. Interesting.
Yeah.
I wonder if they'll notice a difference.
Yeah.
Cool.
I was fascinated about that. Anyway, it is something that I've been thinking about. I've been fascinated about digital humans. I'm fascinated about the uncanny valley. Actually, I love the uncanny valley because I just wonder why it exists in the first place. Like, why do we have this thing, right? It's obviously a disgust and fright thing that allows us to flee people with disease. I think that's the instinct.
I mean, the way the human brain works, we're literally an AI engine. We see differences and inference constantly, and the face is what we see all the time. So any little difference or inference that there is, you pick up on it instantly.
Yep, for sure. For sure. Well, I'm very curious, obviously I was trying to figure out what you guys are doing, and I know you have to remain somewhat secretive, but I'm just trying to get an idea of where you guys are living. It sounds to me like you guys are doing some fascinating work and both collecting and, as you say, compressing huge amounts of data to create a smoother, better, and faster real-time digital human experience.
A candy valley, if you will.
A candy valley. Very cool. Very cool. Well, listen, thank you so much, guys. I really appreciate you guys coming on and being able to share some of this great stuff with me. I can't wait to see some of the stuff. Can you mention the ABBA project? Were you guys involved with that ABBA project?
No, we're just admirers.
No.
Admirers. Okay.
Are there other great work?
Are there certain projects that you guys have been involved with that you guys can mention real quickly?
No.
That are more public. Oh, no. Okay. No, wow. You guys are really secretive. That's cool.
At the moment, no, we can't.
Okay. All right. And obviously, like you guys are trying to stay under the radar, but I'm glad that I was able to still pick your brains and do stuff. I can't wait to find out what's going on. When you guys are able to talk about stuff, would love to have you back on so you can be a little bit more public about the cool things you're doing. You guys definitely have the talent behind you. That's for sure.
Thank you. Yeah, we'd love to be back.
Yeah.
Yeah. Thanks so much for having us. It was really great to talk. I mean, we just love talking about digital humans anyway, regardless. So it's great. It's a fun place to be at, right? I mean, it's just, it's the bleeding edge of a lot of different technologies, hardware, software, AI, machine learning, like just a lot of different things, just, capture technology, like we were talking, all the stuff we're talking about. It's like, you're pushing the limits of absolutely every one of those things to try to get somewhere that's never really been gotten to. So it's exciting stuff.
It is the hardest thing, and I think it's exactly the way that Culley is saying. We are the most discriminatory of this because this is the first thing we've learned from our youth or from our birth is to study a face to know if it's good or bad.
Exactly.
And so I think that this is a one, like you mentioned, it is the pinnacle hardest thing to do in CG. No matter what, because of that emotional bond that we have to faces. So really cool to talk to you guys. Well, thank you guys so much. Appreciate it. Excited to know more. And love to have you guys back.
All right. Thanks
so much. Appreciate it.